Hi students, we're here today talking about lesson 5.6 and this is part 1 of 5.6 talking about the law of cosines. Today we're going to understand what the law of cosines is, when to use it, and how to apply it. You should know that law of cosines and law of sines often work together. Law of cosines is used when we can't use the law of sines and is used typically in problems that are non-right triangles. Let's go ahead and get started. So the law of cosines, we're not going to discover where it comes from, but is basically states that if I take the sides and square them and, well, basically do all this math, we will be able to solve for an unknown. Now, the most common way we use the law of cosines, or what we typically are using with the law of cosines, is if you have your angle A, you're solving for side A. Or if you have angle B, you don't have side B then. And so you would be given 3 pieces of information in each of these. You would, for example, in this problem, you may have been given all of your sides, but you don't know any angles. So therefore, you can't use the law of sines. This allows us to solve for the angle. Or you may have not been given a side and an angle that are across from each other. So you would have been given all the other parts and you do the math and solve for it. Now at the bottom, I do note that angles are represented with capital letters and sides are represented with lowercase letters. Let's go ahead and give it a try. So in example 1, it says solve for triangle ABC given the following information. So angle C, let me get out of highlighter mode. So angle C is 20 degrees, and we'll say this is A. Side A is 11, and side B is 5. Now, as I look at this, I don't have an angle that is across from a side. This is how I know I need to use the law of cosines, because I can't use the law of sines, and we don't know that it's a right triangle. So what I'm going to do is I'm going to identify that I was given angle C, which means side C is what I want to find. So our formula says C squared equals A squared plus B squared minus 2AB cosine of C. Now notice that side C and the angle C are not on the same side of the equal sign. This is the type of problem that becomes very easy to work with because really you're just typing it into the calculator. There's no simplifying that needs to be done separately. And so I'm just going to grab my calculator and I'm going to type this in exactly as I see it. Again, double check that your mode is in degree mode. We are. And I can go ahead and just type it in. So we have 11 squared plus 5 squared minus 2 times 11 times 5 times cosine of 20. And when I hit enter, I get 42.63. Now, technically, 42.63 is C squared. It's not C. So to finish solving, we take the square root. And normally when we take the square root, we would get plus or minus, but we only care about the positive value here because we're representing a distance. So C, or side length C, is equal to 6.53. Now that we know what that is, we can switch over from using the law of cosines and we can actually start to use the law of sines because we now have a side and an angle that are across from each other. That's what this comment is saying here. It says you can use the law of sines after you have found the side. Now, remember that we said we cannot calculate out an obtuse angle using the law of sines. So as I look at my triangle, which of my remaining angles would be the best angle to find? Well, I would say angle B would be the better angle to find. The reason angle B is the better angle to find is because it is across from the smallest side, which ensures that we are calculating out an acute angle. So sine of B divided by 5 is equal to sine of 20 divided by 6.53. Now, some students do really enjoy using the law of cosines, so they choose to continue to use the law of cosines. But law of sines is a little bit faster, and I do encourage you to still use that when it is applicable. So multiplying by 5 on both sides, and then taking the sine inverse of that answer. All right, and when we do all that math, we get that angle B is equal to 15 degrees. All right, so we have angle B up here is 15 degrees. And now we can quickly find angle A just by doing our subtraction with our two angles. So we have 180 minus 20 minus 15, and that produces a value of 145 degrees. There you have it. Again, doing that quick mental check, smallest angle, smallest side, largest angle, largest side. It's a quick way to check if you did your calculations correctly. All right, I have one more example for us today. Again, just keeping it nice and simple. In example 2, it says, find all the missing parts or solve for triangle A, B, and C. They tell us that, let's see, it looks like we have all side lengths. So little a is 9, little b is 7, and little c is 5. So again, notice that I don't have any angle across from any of my side lengths. Therefore, I need to find an angle measurement. And I'm going to need to use the law of cosines. Now, when I look at this, I highly encourage you to use the law of cosines when finding a potential obtuse angle. So when I did my calculations here, I decided to find angle A first. The reason I decided to find angle A first is angle A has to be the largest angle because it is across from the largest side. When I go to set up this problem, I would have 9 squared equals 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of angle A. Now, I really caution you just to pump the brakes a little bit and make sure you take a minute and look at the problem. So this problem is going to require a little bit of balancing to not make an algebraic mistake along the way. And what I mean by that is it's not as simple as just typing it in as it was on the previous problem. In this particular case, we need to simplify this, and then we need to do the balancing. I will also be simplifying the left-hand side. So in simplifying, we get 9 squared, which is 81. 7 squared plus 5 squared is 74. 2 times 7 times 5 is 70. Now, we want to isolate the cosine of A. And in doing so, it means we need to do some balancing. So before I can touch anything attached to the cosine of A, I need to subtract off that 74 from both sides. When I subtract off 74, I get 7. And that equals negative 70 cosine of A. Next, I need to divide by the negative 70. And I get negative 0.1 equals cosine of A. Now we're to the point where we can do the cosine inverse, just like we've seen with other problems. Remember that cosine inverse does work with any number that is between negative 1 and 1. And when we do this inverse cosine, we get that angle A is equal to 96 degrees. All right, so we found angle A. And now we have an angle and a side that are across from each other. So let's go ahead and switch over to using law of sines because we know it's faster. So setting it up, we would have sine of 96 divided by 9 equals sine of b over 7. And going through and doing our solving. So we begin by multiplying by 7 on both sides. And then we use that sine inverse to get b by itself. And in doing all of those calculations, I got that b was equal to 51 degrees. Finding c, not so hard. We can go ahead and take 180 minus 96 minus 51, and we get that c is 33 degrees. Again, that was 180 minus 96 minus 51, and that is how we got 33 degrees, which happens to be angle C. As you can see, the law of cosines is a great process. It's easier to find a side length than an angle, but both are pretty manageable. Again, we use the law of cosines whenever we are unable to use the law of sines, but after that, you can go ahead and revert back to using law of sines if you prefer. Have a great day.